Okay, so I'm again back with another data structure problem, which is again on array. So we will discuss about one more interesting problem. The problem statement is like merge sorted arrays. So I think this is very common problem, which is asked in most of the interviews, uh, specifically in the FANG interviews. So let's quickly go and check statement. So this is the problem, merge sorted arrays. It's easy grid, problem. So you are given two integer arrays, num1 and num2. They are sorted in non-decreasing order. And then two integers m and n representing the numbers of elements in num1, num2 respectively. You have to merge so that they are also sorted in non-increasing order. So you have to merge actually, right? So there are two arrays. Now you have to sort them in non-decreasing order. So meaning ascending orders, starting from the smallest to the biggest. So this looks very simple problem. I mean, definitely the moment you read the problem, the solution comes in, the brute force solution comes in is we just need to, iterate on two arrays. Uh, uh, so num1 and num2, and then we need to make a result array, and then we compare every element of num1 and check it with num2. If it is smaller, store the element, and then move the I and j index respectively. Yeah. So that is a brute force solution, and then you can return the result array as the final answer. Uh, so yeah, so can we do it? I mean, this particular solution, I mean, looks pretty straightforward. Where you are kind of iterating the array two times. Um One is, I mean, both the arrays once actually. But again, when you think in terms of space complexity here, what we are doing, we are kind of comparing every single element of array 1 uh, with the every single element of array 2, and then checking it and then storing it into the result. So there is one problem. I mean, definitely this is the brute force solution. Of course, brute force solutions are not optimized. But what is the problem? The problem here is that we are kind of doing redundant checks again and again within the arrays, because every time when we compare element 1, uh, element at I index in nums1 array with element at j index at nums2 array, those uh, uh, comparisons, they happens, duplicate, like more than one times the same. We are not kind of utilizing um, already existing, uh, I would say, sorted array concept. So that is something where I would like to discuss about how an optimized way we can do that. So yeah, so let's start with the basic skeleton of the class, and then we'll see from there how we can do that in place merge rather than comparing every single time, right? Go and I create a class. So let's say merge sorted array. Yep. And copy the problem statement. Copy it from here. Paste it here. This is example 1. This is example 2 and example 3. Yep. And now let me write a main method. So what is the input? It will be input, logic, output. So input is my int array, num1, okay, which is, let me copy this, and then integer m equals to 3, and then other array is num2, sorry, and this one is 256, integer n equals to 3. All right. So yeah, so there uh so now you see here, this num1 has uh 1 2 3 0 0 0 elements, num2 has 2 5 6. We're not considering 0 elements, so the size here m is 3, and this also has 3, right? Now let's write and work to the logic part. So what we have to do, we have to merge this particular array. Okay, of course we know the brute force solution, but we are not going to do that brute force solution. Instead, we are kind of planning here to do inline merge, meaning uh, either of num1 or num2. Okay, we would not be creating any new array for the result. Instead, we will be merging it at inline. So uh, let's say merge and then num1. Okay, let me nums, nums, nums. Okay, and then m is m, nums2, and this, and then output would be SOUT arrays dot to string, and I can just press right m1. So let's say nums1 will be the inline array which I will be finalizing, right? So yeah, let's create this method. So I'll be creating this method. Let's say this is the method. So now what we have to do in this particular problem, the merge problem, I mean merging two elements, two arrays in one is very simple problem, right? But when those arrays are sorted, or let's say when those arrays are already in uh, any ascending or descending order, we can definitely take the advantage of that, right? So that we save some time in the time complexity. So that is what we would like to do here. So what I will do, I will try to iterate the array. Okay. uh, so from the, I would say, end, and then what I will do, I'll try to finalize my merged array, which would be nums of 1, uh, and then place all the elements in correct order, which is ascending order, non-decreasing. So let me start the pointers. So integer I is equals to m minus 1, integer j is equals to n minus 1, and then integer k is equals to m plus n minus 1. So this will be my last index of merged array. Okay. So this is last index of merged array, and these are the uh, last index of uh, nums2, and similarly this one is last index of nums1. Yeah. So these are the index because we want to start from the end. So that is why I just created these variables. Now, quickly, explaining you uh, why we are starting from back. So this is very important to understand, uh, that why we can't start from the beginning. Yes. Starting from the back of both arrays when merging two sorted arrays into one has really some specific advantages. So first, you avoid overwriting elements in nums1. So what does it mean? So when you start, let's say by starting at the end, you place the largest element at the end of num1, right? Without overwriting the smaller elements at the beginning. Because at the end, what you have to sort the finalize the merge array in ascending order. So meaning the maximum, the largest element should go, at the end. So that is the reason why when you're starting at the end, you place the largest element at the end of nums1 array without overwriting the smaller element at the beginning. This ensures that as the elements are compared and placed, they don't interfere with or overwrite elements that have not been processed. That is one. Okay. Second is whenever you are starting from the end, okay, nums1 has extra space at the end. So initialized with zeros, you see here, right? So allowing nums two elements to be merged directly without needing additional space. So that is also one of the advantage. Merging backward fills this extra space directly, okay, making the solution more memory efficient. So the moment I saw these zeros, I got an idea, okay, let's start with it, backfill it. So efficient time complexity, since each element is processed only once, this approach has an OM plus 1 time complexity, okay, which is merging two sorted arrays. Okay. So let's write the code. Uh, so of course, let's say while uh, I would be greater than equals to 0 and j should be greater than equals to 0. And then very simple. So here compare um, elements from end and place the larger one at the end of nums1, right? And that's what I said. So if nums1 of I is greater than nums2 of j, what does it mean? It simply means that nums1 of k minus minus, okay, because we are finalizing the kth, like the last position is equals to nums1 of I minus minus, right? That is why. So nums of I greater than nums2j. So meaning nums I is greater. Okay. At the end, it is greater than nums2j. So why not finalize the nums last end position with this nums I position and then play around with the indexes. Else, if it is not like that, just opposite. Okay. So I do the same, but instead of, uh, all right. Okay. Here we go. Else, this would be to j minus minus, right? And if that works, so this while loop will run, all right? This and this will run. And then once this while loop is finished, yeah. So once this while loop is finished, then what we can do, because these arrays can be of different size, right? There is a possibility that I and j are still not reached to 0. Okay. If they both are, same size, then it is okay. This loop is the final, iteration. But there is a chance that these out of these two, because I will be my final, but j, of course, I will be finalized because I will be iterated up to the beginning, which is 0. but there is a possibility that J is not, finished. So what I will do, we have to copy the remaining elements. This is always a common concept. Remaining elements from nums2, okay, uh, into nums1. So that is always there. So I would say J still not reached to 0, and then nums1 k minus minus is equals to nums2 j minus minus, and we'll wait till end. And then once this is done, I think that should be our final answer, right? I mean, everything is done in place, and let's run this solution and see what it out. So 1, 2, 2, 3, 5, 6. And what is the expectation? 1, 2, 2, 3, 5, 6. Okay. Now let's say, yeah, so it should actually work. Time complexity and space complexity, let me add. As I said, O, M plus N, because there are two arrays and we are doing it in one iteration. I mean, of course, like two arrays are counted. You see here, let's say this is common, M or N out of those total number of elements which are common, and then one more time the remaining elements. So that is why we say M plus N. And then space complexity is O of 1. Why? Because we did inline, right? In place much. We have not take any extra space. So yeah, that pretty much all. Again, why I choose to start from the beginning? There are two reasons. One, first, I do not want to like overwrite elements in nums1. By starting at the end, we place the largest element at the end of nums without overwriting the smaller elements at the beginning. Okay, because that's the advantage. Second is because we already have 0, 0, 0 in place, so it's better to use of space. Okay, and this also is like processed only once. Let me copy this solution and try to paste and run this solution into LeetCode, how it works. So let me place it here. Run. Okay, this is accepted. Submit. There we go. It is 100%. So all good.